Thank you. This is a presentation of today. I present you. I'm mainly focused on facade building envelope to meet energy efficient building. Just a bit of outline of my presentation. First of all, a company profile, just to present who Focchi is and how it's positioned in the market. And then what is research in Focchi. Point out from one side the research and development department activities, and from the other the innovation project in energy efficient building, and then some conclusions. Here's the company profile. Focchi was born in 1914, so has more than 1 century of life, and was born to manufacture prompt. This was a rural area, and so the prompt was something requested. The evolution of the market bring Focchi to realize today building envelope. This is our headquarters in close to Rimini in Italy, and today we have more than 100 of turnover and 220 people involved in the company. Here's what we manufacture. We engineer, manufacture, and install building envelope for, let's say, architectural building. We are active in 3 markets: Italy, UK, our main market in this very moment, and United States, where we have just entered for, let's say, 1 year and a half, and we are trying to be local in that specific market. Here I am. I entered in Focchi in December 2017. I'm an architect, PhD in architectural urban planning, and the innovation manager in Focchi. The research in Focchi. Let's say that there are 3 big ways to research in Focchi. The first is the R&D activities, so the R&D department. The other is the innovation department. The difference is, I'm going to show you what is the difference. The first is a market pool scenario, because there is a specific request by project. So the R&D department answers to specific architect, general contractor request with the building envelope that could be designed and manufactured in line with the specific of the project. There are suppliers, there is a continuous improvement in what Focchi relies for this product. The innovation department makes something different. Try to figure out some solution for future market, for future strategies to be implemented inside the company, considering both product as well as process of the company. Let's say that we are open to both incremental and disruptive innovation in this scenario. Here, the activities of R&D department, so specific request, architect, and so on. These 2 cases, one in United Kingdom, the other is Solar Cab, United States, and this is innovation department. So you can see the automatization of building construction. At the case of Festus project, this is an European project to realize a robot that could install facade, but also some other activities related to new glass or comfort for the space. Here's the R&D activities. I've just taken 2 examples just to show you what are the requests of the market, because it's important in this historical phase to figure out what the market asks, what is ready for, and what are the perspectives of further development. This is a Riverwalk. The Riverwalk project is a residential building. It's been designed in 2014, as you can see, and the request was to achieve here these transmittance. These are very, as you can see, it's very high, but it's a sort of average between different units of that create the building envelope, so vision part and opaque part, and this is the result requested by the architect, general contractor, and so on. But there's also something worse, because as you can see, this project, Dollar Bay in London, has very higher transmittance. So how is it possible to meet energy efficient building request with these transmittance? Let's say that there is a balance. It's a balance between what is requested by the norm and what is requested by the cost, because a developer wants to save money, and so spend less for the construction, but create something that could be sold at a very high price. And this is the case. This is another residential building. I'll not tell you about the cost of this apartment because in my case not affordable, but it's not in my case. As you can see, this is made by glass. So, whole a building made by glass, obviously, this is quite normal. So, where is the R&D department is working on this range of transmittance in this very moment. This is an historical trend. The blue one is the tertiary in Italy, the tertiary in UK, and residential in UK. And as you can see, there is this range between 1 watt on square meter Kelvin and 1.5. And this is quite high. Is an average, obviously, but let's consider this what market asks now. And, okay. In conclusion, we'll try to figure out something to work on. Then there is, on the other side, the innovation project. So figure out a solution that could anticipate new products, demonstrate the applicability, and also identify some new market useful to meet energy efficiency standard. In this case, I'll present you today two different projects. One is Ensolate, and the other is EarnDeb, are both projects funded within the Horizon 2020 program. And as you can see, one is started in August 2016, the other in, this is wrong, okay. Okay, this later on. And Ensolate. These are two different projects also for the purpose behind this project. Here are the objectives. We know exactly that European strategies for energy efficient building ask for decrease energy consumption, improve durability of material, and reduce total cost. And Ensolate tried to figure out a solution to meet this target. Let's say that the background is one of the retrofitting of facade, but as well the realization of new building with prefabricated solution. And in this frame, with this prefabrication is another important issue. Focchi tried to answer specifically to the request of these innovative technologies. What are the main objectives of Ensolate? Is the creation of an Ensolate foam, is a fire-resistant foam. You know, the fire issue is something in this very moment quite challenging for envelope, but in general for building, especially after the last disasters occurred. The realization of an Ensolate vacuum insulated glass. This is something very interesting for that could represent a step in energy efficiency of glazed building, and to integrate all these components in an Ensolate module with an expected transmittance total of 0.6, so very low in relation to the standard that now is requested by the market. Here's the foam. This foam, different formulation with quite low transmittance, a high fire resistant, considered that it is a polyurethane based foam. And the challenge from our side is to include this solution inside the facade. Obviously, this could be very interesting because mineral wool that in this very moment is a standard. Yes, it's a class A for fire resistance, so it's very good, but the transmittance is much higher than this polyurethane foam. So we need to figure out, is it possible to integrate this foam inside the facade to meet different code. And then there are the components developed for the vacuum insulated glass. In this case, there is a sealant. So the The vacuum insulated glass is mainly composed by a very small cavity between two glass panes. We speak about less than 1 millimeter, 0.3 millimeters, that is completely vacuumed. This vacuum allows to achieve higher performance of transmittance at around 0.3 for glass, so decreasing the current standard of glass. And this is a sealant, the way the pane are connected to each other. There's the getter. So why the sealant is used to connect the two different glass pane and to avoid the transmittance of air from outside to inside, from the internal part of the vacuum insulated glass. The getter is activated and work in the case some air goes inside this vacuum insulated glass. So to preserve the vacuum as long as much possible, to achieve those durability parameters requested also by the project. All these components have created this one. This is a prototype, is a first prototype of this dimension, but we are scaling up to arrive to 1.5 for 2.5, so something that can be also commerciable in the market. There is, just to give you an idea, the sealant obviously all around, and the getter inside. Here you can see the pillar, because obviously a vacuum insulated glass has the pressure of external atmosphere, and it needs some pillar to allow the glass to remain in position. Our purpose is to integrate all these components and to demonstrate to the market this is our solution quite ready. So we try to demonstrate how the technological readiness level of these single technologies can be integrated in a solution with higher performance. These are the first design of the Ensolate modules. So as you can see, this is the vacuum insulated glass, and a first profile that was developed to meet thermal performance, decrease thermal bridge, and so on. To arrive, meeting also obviously architect request, because as we have seen, we are the architect are not directly our client, but they are indirect our client, because we need to answer to their concept on building. So also the request of architect, in this case Unstudio, that is one of the partners of the project, request to adopt some solution, to fix some point of frame, and having a final more aesthetical appealing solution. And this is the final result. So as you can see, we have decreased the dimension of the existing glass. In this very moment, it's not possible to achieve this transmittance with the current glass, neither using a triple glazed unit that could represent in this very moment the commercial available solution. And this is the frame with specific solution with thermal break, foam inside profile, and so on. And this is the Ensolate. So demonstrate the applicability of this solution to meet higher standard in energy efficient building. We are using our headquarters as one of the demonstrator of this application. So we replace some glaze, these are triple glazed unit, with our vacuum insulated glaze. And that is completely different is the case of Renweb. Renweb is a project that focuses on the renovation market, wants to provide a prefabricated solution useful to meet architectural requests, developers, but in general owners need to renovate their building, to reevaluate their property, and so on. These are the targets, so cost reduction of the system, energy consumption reduction, and renovation process. It's quite interesting because the main focus is to improve the number of buildings that are renovated in Europe, moving from 1 to 3, that is the target we have. So also figure out a solution that could join all the elements. It's quite challenging because there are different issues to be taken in consideration. This is the concept behind the RenoZep, so integration of different technologies. We are speaking about the realization of a prefabricated building with multifunctional activities, so solar collector, photovoltaic, prefabricated window solution, as well as sensor and actuators for the control of indoor comfort. The product is being analyzed on the market because we are not realizing anything new with product, but we are trying to use commercial products and to integrate them in a standalone solution with specific installation of the product. We have defined limits of the existing building because we need to understand what are the building's boundary conditions and how a new plug-and-play solution as the RenoZep facade can meet these limits. And this is schematically the solution. So the existing wall is not expected to be removed, but remain in position, and we go over with a new prefabricated panel. It's an industrialized panel, so made with an aluminum frame. I'm going to show you later. And these are the thermal performance of this facade. It is a quite deep solution. We arrive to more or less 350 millimeters, but it's something related also to the use of mineral wool instead of foam, or the maintain of this cavity useful for the bracket installation and the installation of the panel outside. Here's the unit. So there are 4 units designed. One is a so-called opaque unit, and these are the results we achieved. They are presented for the 2 demo. One is in Durango in Spain with a very low transmittance for this component, and one is Voru in Estonia, so completely thermal environment condition that different. So we arrive here at minus 17 degrees during winter, if not wrong, so very challenging. Windows unit, so same prefabrication but integrated Windows monoblock, windows, and so on. As you can see here, also direct cast, we can achieve lower transmittance. Solar collector, because if you want to produce energy, this for heating and this for electric. And as you can see, we have tried to not only answer to national standard, and it's something that we answer to in both cases, but also to provide a single solution that can be adapted in the case. And these are the first prototype, so completely made off site and ready to be installed on site. Here's the final output of the RenoZep, so a platform to manage all these aspects, where the facade is one part. So what facade can make is an enabler of the process and useful to realize all the renovation. Some conclusions. Let's say that the first is a business problem. There are owners request to be cost effective, but the owners and developers of this building, renovation, so on, are not the one that will decrease the energy bill for the management of the building, but it's up to facility manager or tenant and so on. So how can we match between the necessity of developer with the cost safety of someone else? There are a lot of technologies that are improving, but we need to find out how they can be cost effective. As we mentioned before, we need to meet these cost effectiveness solutions. It's not enough to know that it is very energy performing, but we need to have something that can be commercial on the market in relation to existing solution. And then we need to figure out some solution for new market. In our case, that is a renovation building. So hypothesizing new business model just to join all these aspects I have mentioned. So new technologies, new performance with the cost effectiveness of the solution. That's all. Yep, sure.
What about the cost for these solutions? Are like the ones that...
For this one?
Yeah, the one that you are developing. What will be the cost
or let's say that this one is expected to be around in this moment 800 euro per square meter,
So it's still like the how you-
completely installed.
Okay.
So procurement of material, detailed design, installation, it's 800. It's more expensive than an ethics solution. So, but it's different. It achieves different performance, prefabrication time, it's low intrusive, and so on. Obviously, if we speak our standard solution, it can, so for new building, new project, new design, new system design, and so on, it's around 2000. It's